start recording. Lighting, I think, is not as good, but we are doing it anyway because I'm here, you are here. I want to work 2 hours, guys. Let's do it. ChatGPT. Okay. My last thoughts. What did we want to do last time was email, update people that we are going to math of LDA. Before that, I want to run some more simulation. We are done with LDA. What is this? And we are proud of our own algorithm. Our algorithm's main issue may be it's slow. It's a slowity. No, it's low speed. Whatever. What is the slowness? And we wanna, maybe we need it, we may not need it. Actually, I was thinking, well, if I have a big data set, I just pick 100 of those click sessions and I will run my algorithm on it. That will be pretty good slowness. And that's one thing. The other thing was like, okay, we also noticed our algorithm is pretty robust when it comes to estimating the numbers, even when we give wrong Q and P to the algorithm. So I want to figure out how robust it is before jumping to the mathematics of LDA, before jumping to how we can improve the speed. So for this, we don't want to do LDA anymore, and we want to run this part. This time, the tests I have in mind is, first of all, let me share it with you. Okay. So our Q's are like 0.2. Which one is it? This is the data generation. We have Q's of 0.2 and R1, R2 of like 0.9 and P is 0.7. Q and P are the numbers that we give for estimation, like Q hat and P hat. Now let's go here. I want to generate some more plots. So here I am going 0.4 and P is 0.5. Sounds good to me. So we have this one. Let's go for like, if I make it 0.2 and make this completely up. Okay, 0.7. We cannot go 0.7, by the way. Yeah, so maybe we need to speed even if it is not for, because otherwise we don't have large enough data set to check last items. Let's go 0.2. That was 0.2, right? Actually, this is the one that we cannot make it very big. This one can get big actually, so no problem with it. This is let's go. But this one probably, my intuition is that if we are quitting, we are assuming that people are quitting with probably 0.7 at each time, and we receive clicks at like items at the end of the list. It means that the only intuition with this wrong assumption is that so those items at the end have great value. And I'm making P 0.2. I just want to see how it works. I don't know. So how can P, before let's check how P can affect us. So the thing with P is that P says the thing with P is that we only have Jesus, two groups, right? And if P is like from group A, we say, all right, okay, that's the bias happening. For example, we are generating our data with P, which is 0.7. Yes. So with 0.7, users are from category A, right? Now we are saying actually our P hat, our wrong assumption as with P equals 0.3. I think P should be fine, even if we flip it. It should be fine because it says, all right, the other category. So once we see users from the other categories, clicks from other categories, it should be very strange to us. But the thing that makes me say, okay, it doesn't matter is that we just know that with two probability, people belong to two categories. We don't know which items they click. So I think P should have actually a kind of symmetric property, maybe. Like it is robust, invariant against complement. Let's check it. That's my intuition. All right. Oh shit! Sorry. How many? What is the? Is it 200? Number of sessions. 200. Yeah. Okay, 200 is fine. Yeah, this algorithm is just slow. So. Mm. Okay, finished. 90 seconds for two. Look at that. R hat. So 2, you can see that overestimate on the other category. Okay, lower estimate. And look, yeah, as my intuition said, because we are assuming that people exit quickly. Now getting a click at the end of the list means those items have a lot of values, and we can see that now their score is like almost 1. what else? 9. But still, the thing is that if we put a 0.5 threshold, this algorithm is working. 0.9, 0.9, 0.9. So what are the items I want to see? So now items 0356. 0, 3, 5, 6. 0, 3, 5, 6. So, like, those are dangerous. These are dangerous numbers. You can see that. They are getting close to 0.5. And I feel it's pretty good. Let's plot it. Is it in edit? All right. So yeah, this is data for our algorithm with p equals how much is it? 0.2 and qi 0.7 and I want to also add that I want to say so let's go another range of numbers. Main data is 0.2, so let's go actually 0 0.5. And P is 0.4. I don't know, just want to do some numbers. Yeah, I get it. There are two parameters at the moment. And you may say, oh, I just want to get an intuition. I also want to make it 100. Fuck 100, I'm going. Dude, I'm so happy you're here, honestly. I wouldn't do this. The fact that you're here makes me work harder. So thank you. Um, thank to myself. Sunday afternoon, I'm working. Okay, thanks to myself right now because I came work here. Also thanks to myself who decided to make this project really cool because I can feel that I have some passion for this project. It is engaging. I love it. Mm-hmm. So again, 90 seconds, and you can see that, oh, actually the numbers are worse this time. Why? Uh, oh, numbers are pretty bad actually. 0.4, that's terrible. Why? What did went wrong? What did go wrong? So second group is also terrible. Are you fucking stupid? Why did they do that? Still good. Hmm. 0 and 3 should be in the same category, which are 5 and 6, 5 and 6. 6 is 1, 2, 4, 7, 8. 1, 2, 4. That's a bad 4. Sorry, 1, 2, 4, 7. 7 is a bad 7. 8 is a bad 8. 0, 3, 5, 6. 0, 3, um, 5. That's a terrible 6, by the way. So let's find out. Let's find out. All right. It seems if we change two of them at the same time, we don't get the results we collect. First of all, I don't wait. I don't want to wait too much time. So let's make the number of sessions to 100. Um, Also, let me check this part. Can be slow. Uh, what are you doing? Is it slow? Maybe it's not the button on your right. It's a slow 90 second or um, 200 sessions and requires input parameter P and Q. It's a slow and using categories robust. Okay, we were talking about robustness and let's go chat GPT. So restart and clear output. Yep. We wanna see So RP is 0.7, Q is 0.2. Um, let's make the real data 2, 0.2, 0.2, 2, 2, 2, 2, and just let's change values of p. All right, this is 0.2. We will make it 0. Okay, uh, 0.7. We want to go and check all the values and changing the p, swiping, going over p. Did I generate the data? I don't think so. Did I change 100? I don't think so. It's taking some time. Oh, I changed. All right. Wow, even 100 is taking some time, huh? Oh, 45 seconds. As long as it is linear, I think it's pretty good. Maybe we are fine. We can do an offline test. Where is it? 90 seconds. Click. Actually, I don't like to say it is. It may be slow. 45 seconds. 400. And I want to say so we kept the Q the same and P alright. So, well, actually, it's doing terrible job for the right value of data. How is that possible? So, wait a second, that's crazy. Let me check. Q, yeah, okay. So for right value of parameters, we are getting a worse result. That's funny. So it is 0. Wow, it's crazy. 0, 3, 5, 6, 0, 3, 5, and 6, and then 8. This is terrible number. And then we have 0, these are 8, 0, 7, 9, 9, 9, 0, 3, 5, 6. Wow, that's crazy, right? Um, all right. I have a bad feeling, honestly. I'm like, okay, we wanted to fix it being slow. Now we are finding more issues with the code. What is the point of it? What are we doing? Are we coming up why our model sucks? That doesn't sound good. Yeah, you found one issue, go fix it. Well, we had an assumption that, alright, our model is robust enough to P and Q. It's a good assumption. Honestly, I don't like this. I don't like this simulation. They are being negative. They are telling us, like, reinforcing the idea that it doesn't. It is still working. That's the thing. It is still working. Let's have our assumption. Let's go deep inside and yeah, okay, I'm gonna ignore. We didn't do this simulation. Let's just stay positive. What is the point of it, by the way? It is not robust to Q and P. Fuck that. Who wanted it to be? We are gonna come up with an algorithm at the end of the day that will guess P and Q. If we are going to the heart of LDA. I don't know, what is the point of it? Like, we wanna find more reasons of why to do the same thing. It doesn't change our action. At the end of the day, we don't want our current algorithm to ask us P and Q. That's for sure. Why are we doing this? It's waste of time. I don't want to do that. So I'm not gonna do that. Good. Fuck it. So that was a bad idea. And then we wanna say it's a slow. We wanna make it faster. Dive in LDA to see if we can improve the efficiency. ChatGPT 01. Or we can also ask ChatGPT to improve our current algorithm. Sounds great. I actually like it. Let me check if I left any note for myself. What to do? Yeah. I feel if I do this, it will be mental masturbation, to be honest. Only if every time I come back home, take off my clothes, empty my pockets, my life will be 10x. Smells like my gum. Trident supported our video for this session. Smells really good. Alright, Alright, so I'm gonna delete this voice. And then I wanna add, like we were talking about last time, our algorithm is slow. Do we need to have a super efficient algorithm? What if we just, I give the algorithm the 100 strings with the longest clicks and then run it for 45 seconds? Is that enough? Before that, I wanna email Esan and update him about the situation. Alright. Yeah, just a short email. Um, finding. Um, um, uh, Oh, that's it. Alright, I sent to a son. Let's get back to our speed issue. Oh, let's, okay. Let me download this as well. Where is monster training to? Alright, check, LDA is not good. Okay. So, what is wrong? Okay, forget everything now. We want to see what is wrong with this speed. We can go inside LDA and we can find what's up with LDA. And I wanna know. Yeah, let's run the speed test. This time I wanna say keep the numbers. We are gonna make it. I want to see how it changed. So we did 100, it took like 45 seconds. We did 200, it took 90 seconds. I want to see if it is linear or what is it? 300. Like it should take 2 minutes. And I can speak for you here. So we can talk to ChatGPT. Actually, I like to know. Alright, my algorithm right now, I feel it is slow. I don't know if it is truly slow or not, but for 100 click sessions, it is taking 45 seconds to run the algorithm. For 200, it's taking 90 seconds. And why should we have, like, okay, I know why we want to have a fast algorithm, but why I want to know. So if you have a lot of click sessions data, like, I don't know, thousands or millions, can I just take take 100 of them out of random and just give it to my algorithm instead of coming up with an efficient algorithm that can study in fucking million data set or 100 or 1,000 data set. I just get 100 of it, sample 100 of it, and that's fine.
Sampling a small subset of your data, like 100 sessions, can definitely help you get a quick sense of how your algorithm performs on a small scale. However, relying solely on a small sample can lead to misleading results. If your algorithm isn't efficient enough to handle larger datasets, you might miss out on important patterns or introduce bias. When you have thousands or millions of sessions, sampling can be a useful technique for testing or prototyping, but it won't replace the need for a scalable solution, especially if you want accurate and comprehensive insights. It's also important to consider that random sampling might not capture rare events or the full distribution of your data, which could impact the performance and effectiveness of your model in real-world scenarios. So while sampling is a good start, aiming to optimize your algorithm for larger data sets will help you get more accurate, reliable, and generalizable results.
What if our assumption is that each click session is independent and IID in a sense? And then I think we need to have enough number of samples so that people from both categories are being seen. And if I have like 100 samples, right, and the probability of one group being 0.1, so we have 10 samples from them.
Right. With a probability of 0.1, you'd expect around 10 samples out of 100 to come from that group on average. The larger your sample size, the more reliable your representation of both groups will be, ensuring that your estimates are more accurate and stable. Does that align with what you're aiming for?
Honestly, I feel like 45 seconds. Oh, actually, it is linear. Alright. Very funny. Haha. Do you see? Yeah. So 135 seconds. Our running time is linear. Let me add it too. It sounds it is linear, so. What is it linear with? Um, so this current algorithm is linear. So it seems my current algorithm has a linear uh, efficiency or whatever, time consumption. Like uh, when I multiply the number of data set, the size of the data set by a constant, the time it takes also multiplies by the same factor, is multiplied by the same factor. Is there any way to improve it?
If your algorithm's time complexity is linear, that's already quite efficient for many tasks. To improve it further, you typically look for ways to reduce the amount of work per data point or leverage more efficient data structures or algorithms. For example, if there's any redundant computation, or if you can pre-process some parts of the data to make lookups faster, you might gain some speed. Another approach could be parallelization. If your data can be processed independently in chunks, running the algorithm in parallel could reduce the wall clock time. Are you able to parallelize the process or streamline any steps?
Alright, let's ask O1 what's up here. wanna add file, or I wanna give my code. Well, I cannot chat you, Jack. What is 03? 04. From 40 we went to 04. And what happened to 01? 04 great at visual reasoning. 04 mini fast as advanced reasoning. 03. Let's go for mini. This is fast, you said? Alright, let's go ahead. I don't need advanced reasoning though. I love that. Wow, this is beautiful. N is not a big issue for us here. N is the number of items, right? M is the number of users. That's the issue. And 3, I don't care. I want to see at most 20 items. So it is linear with the number of users. Why does it take so long? 24 seconds. Big picture view. Your EM style routine spends almost all of its time numerically differentiating the log likelihood by the finite differences. Because you're perturbed one coordinate at a time, each gradient call recomputes the entire log likelihood n plus 1 times n number of users, length of a linear, number of items, lengths of RA, RB, or Q, doesn't matter, I max iteration, outer optimization iteration, which is 1000. Here, I max iteration, LR, ITU, max iteration is 1000. Alright. Initially, okay. Because you have one coordinate at a time, each income with the entire log likelihood and the cost of one log likelihood evaluation goes over the M users and for each user call. So the users are independent, so and this is it. Probability of subset click 0 based. U R A Q, U R B Q. What is it? Okay. These are not big numbers, by the way. N plus 1, n is 10, nothing. You want to add features? Is worst case. Finite difference gradient. Alright, how you could step it up? Bottlenecks are finite difference gradient, drive and analytic gradient for use automatic differentiation. That's cascade. Honestly, I don't like it. Rough effect on big O removes the extra factor of n. By the way, it is affecting n. N is not our biggest issue here. Dropping each iteration to theta mn instead of mn. N is 10, so what? Alright, yeah, I get it. It is like 10 times faster. It makes it 10 times faster. Alright, fuck it. Recomputing identical terms ui given RA once per coordinate or reuse multiplies by a small constant rather than n. Okay. Python loops vectorize likelihood and gradient numpy or more to C++ Cython. We have Cython. Python. Huge constant factor speed up, mini batch or stochastic ascent. Subset of users each step replaces m by mini. Oh, that's what I was thinking. Use a subset of users each step at each step. Bottom line, with the current finite, okay, I was thinking like we sample like out of any number of data sets we have, we get 100 of them and then run the 100 of them. But now it says not at each step of the likelihood shit you wanna get 100. Within the current finite difference, when the running time grows quadratically in the number of items, that's not a big issue, and linearly in both the number of and after iteration. What is theta? Oh, theta is in lower one. It's not just a lower band, it is a tight band, alright. Both upper and lower band are at omega is lower band. What else? Alright, Ehsan replied. I have to. Okay. Email to Munzer. Dude, I'm like a CEO here. What did he say? Legal department. fixed day. September, Tuesday again, Sunday. What is Easter? Fine. Tomorrow. I wanna go wrestling. So let's go. Alright, listen. Tuesday. One PM. Then I want to say, where is the location? My Zoom. And I wanna say at guest. Please. Of course. Okay. Tuesday. What is this? I just sent this invite and I'm checking if I sent it at the right. So honestly, let's go deeper inside the mathematics behind LDA. Because right now, alright, let's ask ChatGPT if it can make our code more efficient. Can you make the code more efficient? Which one is great at coding? O4 mini high. More models. For O mini, where every data is good for writing external. Okay, this is at coding. Alright, I did the chat GPT. We don't have O1 anymore, by the way. We have O4. It's becoming crazy. And vectorize as much as possible in NumPy. This drops the per iteration cost from OMN square to O. Can you explain which parts? Yeah, I want to understand my fucking code for sure. Oh, what change? Okay, it's explaining itself. Oh, dude. Oh. Change avoids faster analytic gradient. We no longer do n plus 1 likelihood calls per coordinate. Instead, we compute. How did you compute the gradient per user by a single pass up to the last click? What does pass up mean? Mixture gradient in one go. In one go, each user contributes one weighted copy of its gradient to both in and in. Total cost per EM iteration is now O of M and compute VAPB for each M user instead of O of M and square. NumPy vectorization. You can further speed up the small Python loops by turning clicks list into sparse binary matrix or using NumPy.jit. Clicks list into sparse binary matrix. Alright, let's take a look at the code. How did you compute the what is the formula for it? It doesn't even have the gradient. Okay. RAJ. I have doubts. Why is that true? It's not true. Hmm. I don't get this line. How do you say that? I don't think this is not correct. Exactly. Exactly. We don't have any log. Now recall that. Ah, okay. I see. Now I get it. Alright. Okay, makes sense. Okay, math is correct. And no, I don't think this is correct for our cascade model. It is not in my paper. What are you talking about? What are you didn't even look at my paper. The fuck. What about probability of no clicks? That's the thing. Yeah, I was correct. Like, what the fuck? I don't know my own paper. This is probability of click, and then you have probability of no click, which has some terms like this. What about the contribution? There is no that. I made the current car more efficient by okay, memorize dynamic programming and forward recursion over time. So, what are these terms? Why do I look at the phone? Where do you get that formula from? I don't see it. Log, you get the log. Yeah, no RJ, you get the RJ. Alright, that's easy, minus 1 over the TJ. That's true, okay. Where is it? Oh, we have an error. Where is log prop cascade? Well, yeah, where is it? Log prop cascade. Don't look at it. Oh shit, I should not delete that part. And let's see how long it takes. It is taking a long time, so fuck off. What is my dataset size? I don't see it is not 13. 13 seconds has passed and we are not. Oh, actually, that was fast. Dude, this ChatGPT is so good. So I think it became 10 times faster, don't you think? Let's see. Oh, it's error. Where is it? Oh, first line. Let's see if we can. I think it's more than 13 seconds. "36 seconds. Oh, they're all NaN. Just a stupid result. So you can say it's like 1/4 or 1/3, but no time. I wanna make Where should I add this part of the code, motherfucker? What is the E? Okay, it's just the whole thing. Dude, bullshit. You know what? I'm not gonna spend more time on it. Somebody else should. What is this? Muscle. And it takes more time, 48 seconds now. And it's just bullshit. Fucking bullshit. Somebody else come up with an optimal algorithm for this part. I'm not gonna do that. And then I will say, is that it? So I think next step is just jumping into. All right, we learned that our algorithm is linear in the number of click sessions, and also we tried O1 to do a better thing. We have some ideas if you want to improve the code. Let's do the next step, which is diving into the LDA. Perfecto. So I'm gonna play 1.5 probably ramp.
Let's roll.
These chairs, I don't like them. How do we know there exists a hidden flower at the first place? There's nothing hidden in this one. Everything seems otherwise hidden. Unless they have an effect like this, they kill you. Dude, how can he kill me so good? Jesus. Alright, they are very good, That's good. How did he shoot me? Dude, their gun is stronger or something? Where are they shooting from? I cannot get far. Aren't they shooting from here? Dude, I had it on his head. Jesus, don't get closer. Wow, who was the other person? Damn. Oh, dude, I had it. Chill guys, there is no expectation here. Where are these fuckers? Oh, they are all. Where are they? They are dying over there. What is the game? I'm fucking scared. Oof, oof. I'm helpful. Jesus. Who's shooting us? Jesus. No, 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 no. Oh my god. Alright guys, I think it's enough for today.